In ray optics, we study those phenomena of light where light is supposed to travel in a straight line path. Now, the situation where the size of the object is much larger compared to the wavelength of the light. In this situation, light is considered to travel along a straight line path from one point to another, and such path is called a ray of light, and bunch of rays of light is called beam of light. In this chapter, we will have to recapitulate all the topics which we have studied in our earlier classes, like reflection and refraction of light. A lot of things we have studied in class 7, class 8 and class 10. A reflection, bouncing back of rays of light from the surface of an object, is known as a reflection of light. Suppose this is the surface. When ray of light falls on the surface and returns back, then this is known as reflection of light, and the point where the incident ray strikes the surface is known as point of incidence, and a perpendicular at the point of incidence is known as normal, and angle between the incident ray and the normal is known as angle of incidence, and angle between normal and reflected ray is known as angle of reflection. The incident ray, the reflected ray and the normal at the point of incidence, all three lies in the same plane, and angle of incidence is equal to angle of reflection. These are the two laws of reflection. Now, there are two types of spherical mirrors. One is known as concave mirror, in which the bulging edge is polished and curved surface is reflected surface. This is your concave mirror. Another is convex, in which curved surface is polished and bulging surface is reflecting surface. This is convex mirror. Now, important terms related to spherical mirrors, we have the idea of those terms like pole, center of curvature, focus, focal length, radius of curvature. These things you know very well. If you want to revise, you can see the videos that has been uploaded in class 8 playlist. There you can go and see all the details. Now, next thing which we will discuss is sign convention. Sign convention. Set of rules to study about spherical mirrors. Is your sign convention. First is, while drawing ray diagrams, the rays must travel from left to right while doing diagrams. First point. Second point, all distances are measured from which point? Pole of the mirror. All distances are measured from the pole of the mirror. The rays of light which are measured in the direction of incident ray is taken as positive, and those which are measured in a direction opposite to incident ray will be taken as negative. So distance, this is the point from where distance is measured, and this is your incident ray. Suppose if object is here, then to measure the distance we move in this direction, both are opposite, so it will be taken as negative. and if the distance measured is in the direction of incident ray, it will be taken as positive. Heights perpendicular to principal axis in upward direction is taken as positive, and height perpendicular to principal axis in downward direction is taken as negative. So these are the set of rules, sign conventions to be followed in our next discussions. Now suppose we have to prove the fact that f is equal to r by 2, where f is focal length and r is radius of curvature. So derive a relationship between the focal length and radius of curvature of the spherical mirror. This relation is f is equal to r by 2. How can we prove it? So let us see the diagram. Now this ray is parallel to principal axis. So angle of incidence after reflection, it will pass through focus. So if we join the point where this ray strikes with the center of curvature, it will behave like a normal. So angle between incident ray and normal is angle of incidence. This is your angle of incidence and this is angle of reflection. So these two rays are parallel. So these two are alternate interior angles. So I is equal to alpha. And from law of reflection, I is equal to R. So I is equal to R and I is equal to alpha. Therefore, R and alpha are equal. Therefore, R is equal to alpha. So R and alpha are equal. So side opposite to equal angles are also equal. So CF is equal to BF. Now PC can be written as PF plus CF. Now CF is equal to FB. Now as aperture of the mirror is very small, so we can consider FB is equal to FP. So PF plus CF is equal to PC, and PF and CF are equal, which is equal to focal length. So we can write it PC is equal to 2PF, and therefore R is equal to 2F, or F is equal to R by 2. Now next is mirror formula. 1 by B plus 1 by U is equal to 1 by F is called mirror formula. So let us derive this mirror formula using concave mirror for real image. So figure shows you the image formation diagram in which object is placed just beyond the center of curvature. AB is the object and A dash and B dash is its image. Now triangle ABC and triangle A dash B dash C. Triangle ABC is similar to triangle A dash B dash C. So corresponding sides are, ratio of corresponding side is same. So A dash B dash by AB is equal to B dash C by BC. Let it be equation 1. Now in triangle A dash B dash F is similar to triangle MNF. Therefore we can write A dash B dash by MN is equal to B dash F by NF. Since aperture of mirror is very small, so NF may be written as equal to PF, and AB is equal to MN. So A dash B dash by AB is equal to B dash F by PF. Now from equation 1 and 2, LHS is same, so RHS must be equal. So B dash C by BC is equal to B dash F by PF. Now all distances are measured from the pole of the mirror. So what we have to write these distances in terms of the distances which are measured from the pole of the mirror. Like b dash c, you can write pc minus pb dash. bc, you can write pc plus bc. b dash f, we can write pb dash minus pf. Now put its value. Now use sign convention. Pb dash is the distance of image. We are using symbol v for image distance and u for object distance. The distance pb dash is measured in a direction opposite to incident ray, so it is taken as minus v. pf opposite to incident ray, minus f. pc opposite to incident ray, so minus 2f. Now put the values and solve it, you will get the result. Now the mirror formula is same for concave mirror and convex mirror. Whether image formed is real or virtual, it is immaterial. Formula is same. So this you can also prove this formula for virtual image. I have drawn the diagram here and written the name of the similar triangles. Just proceed on the same way. You can derive mirror formula for virtual image using concave mirror and for convex mirror also. Now magnification, it is defined as the ratio of height of image to that of height of object. Now in figure 1 you can see ABP, triangle ABP and A dash B dash P are similar. So we can write A dash B by AB is equal to B dash P by BP. Now use sign convention, you will get the result H2 by H1 is equal to minus V by U. Now here are some solved numericals for your reference. Just go through it. Very simple. You have solved lot of numericals in class 10 also based on mirror formula. The list of questions for practice. Just go through it. Thank you for watching.